So we'll be looking at some special functions today in this lesson. We'll start off with the piecewise function, and the other two functions are actually specific types of piecewise functions. So a piecewise function is a function whose value is defined by different expressions for various intervals on the domain. So here we see different expressions. We have the x plus 3. That's one expression, x squared is another, and 1 is another. So when x is less than -2, so on a graph, here's -2. When x is less than -2, so anywhere to the left of -2, we would have this line. Anywhere between -2 and 2, so here's 2, anywhere in this section, we would graph x squared, and anything between 2 and 5, so 5 would be somewhere out here, we would have the graph y equals 1. So a function whose value is defined by different expressions, so that's this first part, for various intervals of the domain. That's the second part. So state the domain and range of each of the functions. Finding domain and range of functions is important. You need to be able to do that. One way to think through this to find the domain and find the range, it's similar. So domain, what we can do, domain has to do with our set of x values. So if we collapse every part of our graph to the x-axis, so this point, if we collapse all these points to the x-axis, this one's already on the x-axis, this we go up, we would think, well, the x-axis would be covered from here all the way to here. And that is our domain. So what we can do here, this is -1 up to 4. And so we can say -1 is less than or equal to x, and I'm putting the or equal to because it's the closed circle, which is less than the upper value here, which is 4. So that's our domain. And then our range, we can do similarly, except this time we're going to look at our y values, and we're going to collapse all of our y values to, all the values to the y-axis. And actually, these actually cover the y-axis twice. And so our range, the lowest is -2 and the highest is 2. So we have -2. Does it include -2? Well, yes, it comes all the way down and hits -2. So we have less than or equal to y, which is less than or equal to, because this includes the +2. So there's our domain and range. This next one, part B, if we collapse everything to the x-axis, this whole segment would collapse to the x-axis, and this would be covered. This part gets collapsed to the x-axis, and this is covered, but realize this is an open circle, so that's not covered. So our domain here is actually in 2 parts. So we want to go from -8, which is less than or equal to x, and we do equal to because it's a closed circle, up through -3, less than or equal to -3. And then also our domain is from 1 up to 3. So we do it 1 less than or equal to x, which is just less than 3 because we have that open circle. For the range, our range, if we collapse this is actually just 1 point. It just collapses to 3 on the y-axis, so this would be covered. This part is just 1 y value. It would collapse to 1. So our range is actually just 1 and 3. And then our last one here, our domain, what's covered on the x-axis? Well, from -4 up to 2 is covered, and then, -4 up to -2 is covered, and then from 0 up to 3 is covered. So our domain is from -4 is less than, open circle, so we don't put the or equal to, x, which is less than or equal to -2, and from 0 to 3. And then our range, collapse this stuff on the y-axis. So this is covered, all of this stuff. So that goes from 0 to 3. But then we have these other points. So the range would be covered from here all the way to here. This would be open because this is open. So our range is from 0. 0 is less than or equal to y. I'm sorry, that's not less than or equal to. It is just less than because it's an open circle. So 0 is less than y, which is less than or equal to 5. And that's how we can find domain and range if we have functions there already. Now let's get into graphing a piecewise function. So once again, we have different expressions for different intervals. So what I'm going to do first is I'm going to focus on these intervals. So f of x or y equals -3 if x is between -5 and -2. So -5 is right here. So I'm going to just put a dotted line there, and then -2 is here. So whatever this graph looks like, y equals -3, that's what I'm going to graph in this section here, between here. It might be up here, it might be down here, it might be a line, it might be curved, but wherever it is, we graph that in there. The next one's from -2 to 1. And so whatever this graph is, x plus 1, which we know it's a line, that will be in this section. And then the last one, -1, or -x plus 4, is from 1 to 4 in this section. You don't necessarily need to put these lines in here, but it's helpful for seeing where your different graphs will be. So now that we have those different intervals from -5 to 2, from -5 to -2, -2 up to 1, and 1 to 4, we'll go ahead and look at these graphs. Well, what you can do is think of these as 3 different graphs. So y equals -3. We're going to graph y equals -3, which is just a horizontal line, but we're only going to graph it in this section here because it's between -5 and -2. And we look at our inequality signs. This has the or equal to, so it's going to be a closed circle, and this is going to be open. So we want to graph y equals -3, which is a horizontal line. And actually what we have to do sometimes, we graph the whole thing. There's a whole thing, but we only want it in this section. So we might erase some of it or whatever we need to do. So this is from -5 up to -2. And maybe we need to erase this part that we don't want. And then what we'll do is we'll come to another part. Let's look at this part. So that's y equals x plus 1. That's a line. It has a y-intercept of 1. So we're just going to graph this line and a slope of 1. So we can go up 1, right 1, and we can keep graphing points, and then down 1, left 1. And so this is the line we're referring to. But we only want this from -2 to 1. So we only want it in this interval here. So we'll go ahead and erase this extra stuff that we don't need. And we also will figure out what types of circles we put on there. So this is less than or equal to, or -2 is less than or equal to, so this one is a closed circle. And then this is less than 1, so at 1 we have an open circle. And then our last section, we have y equals -x plus 4. So I keep putting y equals because f of x can be written as y. -x plus 4. So again, this is a line, goes through 4, 1, 2, 3, 4. and a slope of -1. So down 1, right 1, down 1, right 1. And so it would be this line here. But once again, we have this specific interval from 1 to 4, so we're going to erase what we don't want. So we only want it in this interval here. So we can erase here, and we can erase on this side. And we figure out what our ends should look like. Here we have both of them have or equal to, so we want closed circles on both of these. And there is the graph of that piece function. It has a horizontal line in this section, a line in this section, and then a line in that section. All right, now we're given the graph and we want to write a piecewise function rule describing the graph. So this graph is in 3 different sections. So we have this over here, we have this middle part, and we have this line here. And so what we'll do is we'll write y equals, or f of x, or let's use g of x. So g of x equals, and we're going to write it in a form kind of like this. So we're going to have our brace here, and the one we have also have 3 parts, so we'll list the 3 parts and put the interval that they should fall in. And so, all right, so let's do this first part. This first part is in the interval from -3 up to -1, so that's going to be our second part here. But what line is this? So we have to figure out what the line this is. Well, to write a line, we like to have slope-intercept form, so if we continued this, that's what the line would look like. And so we see the y-intercept is 2, and the slope is just 1, because we go up 1 over 1, up 1 over 1. So for this first part, it's y equals mx plus b, but our slope is 1, so y equals 1x, plus b, which is the y-intercept, which is 2. So there's the equation of the line, but then we need to put our interval. So we're going to put like this, if, and then we list what our interval is. So if, and we said this was from -3, and we used a less than or equal to, because it's got the closed circle, x, which is less than -1. Just let me reiterate this. When we write this interval, we look at the x values. We don't look at y values. We don't look on the y-axis, we look on the x-axis. Next, let's look at this section. Well, this is a horizontal line, so we know horizontal lines are just y equals whatever number it goes through. So this is y equals 2. And when does y equal 2? So now that's our expression. What's the interval? It's 2, or -2. I said 2, but it should be -2. From -1 up through 2. So we do if -1, it's closed, so is less than or equal to x, which is less than or equal to 2. Remember, looking at our x value. So that gives me that section. And then the last section is this line. This one could give us a little more difficulty, but it shouldn't be too bad. So it's a line, so we know it's going to be y equals mx plus b form for this third part. Well, our slope, if we look here and here, we go up 2 and right 1, so our slope is 2. It's going to be 2x. And now we have to figure out what the y-intercept is. This one's, I think, easy enough that we can work our way backwards and find where the y-intercept is. So if our slope is 2, we go up 2, right 1, we could go down 2 and left 1. That would put us here, which is right now at 1, -1, 2, 3, 4. We could go down 2 and left 1 again. And that puts us at -1, -2, -3, -4, -5, -6. So our y-intercept is -6. And what's our interval here? Well, it is from 2 up through 2, 3, 4. Here's something interesting here. It works out because they meet here. So we could put less than or less than or equal to because it's the same number. But typically we don't want to put a less than, like both at 2, where 2 fits this one and 2 fits this equation. So I'm going to leave it as less than because it still hits this number. And then this is less than or equal to because we have the closed circle. But we could have the or equal to on this one also.